Welcome back. Now that you've learned about reaction stoichiometry, let's try out one more problem. So here we go. In a process for producing acetic acid, oxygen gases bubble into acetaldehyde. So here comes the first question. Write a balanced chemical equation for this reaction. So we start by identifying our reactants and the products. So in this chemical reaction, the reactants are acetaldehyde, which is CH3CHO, and oxygen. Okay, so these are going to be our reactants. And together they are producing acetic acid, which is CH3COOH. So this is our product. Okay. Now remember, when writing out a chemical equation, you need to mention the state or phase of every substance in the chemical reaction. So in this case, acetaldehyde is a liquid, oxygen is a gas, and acetic acid is a liquid. Okay? So now we have to balance our equation. So let's see. On the reactant side, we have 2 atoms of carbon. On the product side, we have 2 atoms of carbon. So our carbon is balanced. Now we have 4 moles of hydrogen on the reactant side. We have 4 moles on the product side. So our hydrogen is balanced as well. But let's take a look at the oxygen. We have 3 moles of oxygen on the reactant side, and we have only 2 moles on the product side. So we have to balance our oxygen. We start by adding a stoichiometric coefficient of 2 before acetic acid. But hey, now you see the carbon is no longer balanced on both the sides. Neither is hydrogen, neither is oxygen. All right, so it doesn't solve all the problem. But if you do remember how to balance equation using moles, so if you carefully look at this chemical equation, all you need to do is add a stoichiometric coefficient of 2 before acetaldehyde. So now let's check if our reaction is balanced. So we have now 4 moles of carbon on the reactant side. We have 4 moles on the product side. Perfect. We have 8 moles of hydrogen on the reactant side, and we have 8 moles on the product side as well. And now let's take a look at the oxygen. So 4 moles of oxygen on the reactant side, and we have 4 moles on the product side. So perfect. So now we have a balanced chemical equation. Okay. So now let's read the second part of this problem. Suppose 20 grams of acetaldehyde and 10 grams of oxygen were added to the reaction vessel. How many grams of acetic acid can be produced? And how many grams of the excess reactant remain after the reaction is completed? Okay, so let's take a look at the solution, and remember, this part will require a lot of math. Okay, so let's start. Let's calculate the molar mass of the reactants. Let's do for acetaldehyde. Now the atomic mass of carbon is 12.01 atomic mass units. And since there are 2 atoms of carbon, we need to multiply this number by 2. Okay. The atomic mass of hydrogen is 1.008, and there are 4 atoms of hydrogen, so we need to multiply this by 4. Okay. And finally, we have only 1 atom of oxygen. The atomic mass of oxygen is 16.0, so this has to be multiplied by 1. Right? So if we add them up, if you do the math right, the answer should be 44.1 grams per mole after correcting to 3 significant figures. Okay? So now let's do the same for oxygen. In oxygen molecule, there are only 2 atoms of oxygen. So need to multiply the atomic mass of oxygen, which is 16.0 times 2. Okay? So the molar mass of oxygen is going to be 32.0 grams per mole. All right. So now after we calculate the molar masses, now we can proceed to the next step. In step 2, you need to calculate the number of moles of each reactant that are present in the reaction mixture. To do that, you need to divide the mass of each reactant by its molar mass. So let's do for acetaldehyde. So if you go back to the problem, the mass of acetaldehyde that is present is 20 grams. Okay, and you need to divide this by the molar mass of acetaldehyde, which is 44.1 grams per mole. So if you do the calculations, the answer should be 0.454 moles. Now let's do the same for oxygen. Now the mass of oxygen that is present is 10 grams, and let's divide this by the molar mass, which is 32.0 grams per mole. And if you do the calculations, the answer should be around 0.313 moles. So we are done calculating the number of moles of each reactant that are present in the mixture. We may now proceed to the next step. In this step, you are going to identify the limiting reagent. Remember how to do that? You need to figure out the number of moles of product that is formed from the number of moles of each reactant that are present in the mixture, assuming 100% conversion. So let's do that for acetaldehyde. If you look at the reaction stoichiometry, 2 moles of acetaldehyde gives 2 moles of acetic acid. So let's write this down in the form of a ratio. Okay, so here we go. So you are going to get 2 moles of acetic acid from 2 moles of acetaldehyde. And if you want to find out what is the actual number of moles of acetic acid that is from acetaldehyde, you need to multiply this by 0.454 moles of acetaldehyde. Remember, this is a number that we got from the previous calculations. So the answer should be same as 0.454 moles of acetic acid. Okay? So now let's do the same steps for oxygen. Now if you look at the reaction stoichiometry, 1 mole of oxygen gives 2 moles of acetic acid. So again, let's write this down in the form of a ratio. So you have 2 moles of acetic acid that you get from 1 mole of oxygen. So if you want to find out what is the actual number of moles of acetic acid that is formed, you need to multiply this by 0.313 moles of oxygen that you again got from the previous calculations, and this number is going to be 0.616 moles of acetic acid. Okay, so what we see here is this: if we start from acetaldehyde, we get less number of moles of product. So which means acetaldehyde is our limiting reagent and it's going to be completely consumed. So the actual number of moles of acetic acid that is formed is 0.454 moles. In the previous step, you calculated the number of moles of acetic acid that are actually formed during the chemical reaction. Now if you want to find out what is the mass of acetic acid that is formed, you need to multiply the number of moles of acetic acid, which is 0.454 moles, times the molar mass of acetic acid, which is 60.1 grams per mole, which you can get by using the atomic masses. So the number is going to come around 27.3 grams, which is the mass of acetic acid that is formed during the chemical reaction. Now we are almost towards the end of this problem, but there's one more thing that we need to figure out before we wrap it up. We need to know how much of the excess reagent was left over. Now in this chemical reaction, acetaldehyde was the limiting reactant. So intuitively, oxygen is the reactant that is expected to be present in excess. So the question is, how much of oxygen is left over? So to find that out, we need to first calculate what is the mass of oxygen that is consumed during this chemical reaction. Now we look at the reaction stoichiometry. So 1 mole of oxygen gives 2 moles of acetic acid. We can write this information in the form of a ratio. That means 1 mole of oxygen gives 2 moles of acetic acid. Now if you want to find out what is the actual number of moles of oxygen that is consumed, you need to multiply this by the number of moles of acetic acid that is formed during the chemical reaction. Okay? Now we can take one step further and find out what is the mass of oxygen consumed. So all you need to do is multiply this number by the molar mass of oxygen, which is 32 grams per mole. Okay, now if you do the calculations, the answer should come around 7.26 grams, which is the mass of oxygen that is actually consumed. Now remember, we started off with 10 grams of oxygen. So the mass of oxygen that will remain behind is 10 minus 7.26, and it's going to be around 2.7 grams. So this is the mass of oxygen that remains in excess. So this brings us to the end of the lesson on reaction stoichiometry, and hope you have a better understanding now. Thanks for watching this video.